Today we're going to talk about the planets. Here are our learning goals. Explain the nebular theory and why there are differences between the inner and outer planets. Describe the differences between the inner and outer planets. And describe the characteristics of each of the planets. Now, we studied the nebular theory before, but we're going to go over it again because it's really important. So the nebular theory says that our solar system was formed by a nebula. And you remember that a nebula is just a giant cloud of gas and dust. Now, this nebula contracted due to its own gravity into a spinning disk. Eventually, that disk formed the sun, the planets, and other things in the solar system that we're going to study next. 90% of all the material in the cloud ended up in the sun, and 10% of it formed the planets and everything else. And we'll go into a little detail. So, this nebula contracted due to gravity, and as it contracted, it began to spin faster, and it formed a disk, kind of like a frisbee. And the inner part of that spinning disk was warmer, and the outer parts were cooler. So in the inner part that was warmer, rock and metal dust were more common. And in the outer part, where it was cooler, ice and gas were more common. So here's our nebula, this giant cloud. It's beginning to contract due to its own gravity. And eventually it forms a spinning disk, kind of like a frisbee. And the inner part is warm, so it's too hot for ice. So rock and metal dust were common there. And the outer part was cooler. So we're going to get some rocky planets in this inner part. And we're going to get some gas and ice planets in the outer part. So all these little particles started to clump together due to gravity. And they formed larger and larger particles, right? So now they're forming larger and larger particles. And gradually, these larger particles clump together to form the planets. So here we see the planets are forming as they collect these larger particles. And eventually, they formed our planets. And here they are in order. And you need to know this. So our inner planets are Mercury, Venus, Earth, and Mars. These are small and rocky. The outer planets are gigantic, and they're made of gas and dust, and they're Jupiter, Saturn, Uranus, and Neptune. Pluto is no longer considered a planet. Now, the inner planets are what we call terrestrial. Terrestrial means Earth-like. They're made of rock, and they have metal cores. We learned that before. So Mercury, Venus, Earth, and Mars are all made out of rock. They have metal cores. Now the Earth is just the right distance from the sun to have a temperature range where water can be a liquid on the surface. And that's important because life needed liquid water to be able to evolve and exist. So we are in what's called the sweet spot. We're just far enough away to be warm, but not close enough to be real hot. If we were further away, the water on Earth would be ice. If we were closer, it'd be way too hot for life. So we're in just the right spot in the solar system. The outer planets are, we call them Jovian planets. They're gas giants. They're made of gas and ice, right? And those are Jupiter, Saturn, Uranus, and Neptune in that order. Jupiter is closest to the sun. Neptune's the furthest away of the outer planets. Now, let's look at the differences between the inner and outer planets, right? We talked about composition. We said the inner planets were rock and metal. The outer planets are mostly hydrogen gas that exists as gas and ice. The surface is different too. The inner planets are solid, just like the Earth. The outer planets are not. The surface is clouds. You couldn't walk on the surface of Jupiter. None of the inner planets have rings. All of the outer planets have rings. The inner planets, several of them, or two of them, have no moons. We have one moon. Mars has two. The outer planets have dozens and dozens of moons, some of them as many as 100 or more. So you need to know these differences between the inner and outer planets. It's really important. So hit pause when you're ready, hit play, and we'll listen to the answers. All right, number 1, explain the nebular theory. The nebular theory says that there was a giant cloud of gas and dust that was slowly spinning in space. Gravity caused the gas and dust to be attracted to each other. That caused the cloud to shrink and get smaller. And as it did that, it started to spin faster and it formed a disk. That disk was hotter in the middle, so rock and metal dust was more common there. The outer parts of that disk were cool, so ice and gas was more common there. All the particles in the disk started to attract each other due to gravity, and they clumped together to form larger and larger particles. Those particles clumped together to form the planets eventually. Why are the inner and outer planets different? Well, the inner planets formed where it was warmer, where rock and metal dust was common. The outer planets formed where ice and gas were common. So let's compare the composition. The inner planets are rock with metal cores. The outer planets are gas and ice. The inner planets have a solid surface you could walk on. The outer planets don't have a solid surface. The outer surface is basically clouds. None of the inner planets have rings. All of the outer planets have rings. The inner planets have few or no moons. The outer planets have many, many moons each. And here they are again. So these are the inner planets. These are the outer planets. We also call these terrestrial because they're Earth-like. These are called Jovian because they're like Jupiter. Jove is another name for Jupiter. So these are Jovian or outer. These are terrestrial or inner. All right, so let's talk about each planet individually. The important things that you need to know about each planet are in the chart in your notes. I'm going to mention some things that you don't necessarily need to know, but just so you understand the planets a little bit. But study the chart in your notes. That's what you really need to know. So Mercury is the closest to the Sun. It's the smallest of the inner planets, which makes it by far the smallest planet. It has no atmosphere. It takes 88 days to go around the Sun, and it rotates once every 59 days. Eventually, it'll rotate at the same rate that it orbits, and one side of Mercury will always face the Sun. It's extremely hot during Mercurian day, but it's very cold during the night, and there are no moons. We haven't visited Mercury. We don't know a lot about it. We probably won't go there. All right, Venus is the next planet out from Mercury. It's Earth's twin by size and mass and gravity, so it's about the same size and weighs about the same amount. It doesn't have much of a magnetic field. It takes it longer to rotate than it does to go around the Sun. What's really important about Venus is it has an extremely dense atmosphere of carbon dioxide and sulfuric acid. And because of that, it has an extreme greenhouse effect. And the greenhouse effect is where gases in the atmosphere trap the Sun's heat. It has a surface temperature of hot enough to melt lead. This is no place we will ever go. We would never survive there. The conditions are extremely harsh. Venus has no moons. This is a picture of Venus. It's covered by these dense clouds. We don't know a lot about its surface other than that we've mapped it with radar satellites. But it's really like hell. It's so hot and it rains sulfuric acid. It's just a miserable place that we will never go to. Right? This is the surface of Venus that we've been able to map using radar. Right? Now the Russians sent spacecraft to Venus. This is a picture of the surface of Venus. This is the foot of the spacecraft, and this is something so they can calibrate their color camera. This spacecraft lasted about 15 seconds after it landed on Venus before it was destroyed by heat and acid. Well, the Russians sent another one some years later. This is another picture of Venus. This one lasted for almost a minute before it was destroyed. The conditions are so harsh on Venus that spacecraft really can't survive there. So we know relatively little about Venus. So the next planet out from Venus is Earth, and past Earth is Mars. Mars is the last of the inner planets. Mars is smaller than Earth. It's only about half the diameter of Earth. It does have an atmosphere of carbon dioxide. Its axis is tilted like the Earth, so Mars has seasons. It has a summer, a fall, a winter, and a spring. And the temperatures on Mars are significantly different than on Earth, but they're not that much different where astronauts wouldn't be able to survive. So summers are, not too much colder than some places in Canada, and the winters are about like they are in Antarctica. So people could survive there. And Mars has polar caps, but instead of water ice, they have carbon dioxide ice. It takes Mars a couple of years to orbit the sun, but it rotates in one day. So in some ways it's Earth-like. And at some point in its past, it did have water, liquid water on the surface. But because it's so small, it wasn't able to hold on to that water, and it disappeared into space. People think that it's likely that life could have existed on Mars, and we're looking for it there with robots, but so far we haven't found it. Mars also has the largest volcano in the solar system, called Olympus Mons, and it has the largest canyon in the solar system, called Valles Marineris. It has 2 moons, and it probably once was similar to Earth as far as its climate. This is a picture of Mars. Here's a polar cap made of carbon dioxide ice. This is a diagram showing the size of this canyon called Valles Marineris on Mars. It would stretch from the east coast to our west coast, and our Grand Canyon would fit in this little box. So it's huge, it's enormous. Here's a little diagram that compares. This is the size of the Grand Canyon. This is the size of the Valles Marineris. So it's really a huge canyon. And this is just a size comparison to the tallest mountains on Earth compared to Olympus Mons, which is the largest volcano in the solar system and is on Mars. Here's 2 pictures of Mars's moons, Phobos and Deimos. We've tried to send probes there but failed. We know a lot about Mars. All right, so hit pause, answer these questions, and when you're ready, listen to the answers. What is the atmosphere of Venus like, and why is it so hot? The atmosphere of Venus is an extremely dense atmosphere of carbon dioxide. The reason it's so hot is because it has a runaway greenhouse effect. That carbon dioxide traps the heat from the sun, so it's hot enough on Venus to melt lead. Why is Earth such a good place for life to exist? Well, Earth formed just far enough away from the sun to be warm but not too hot, and close enough to the sun where water could exist as a liquid on the surface. So it's kind of like Goldilocks. It's not too hot and it's not too cold. What's the atmosphere of Mars like? Well, Mars has a thin atmosphere of carbon dioxide. Why do people want to visit Mars and not the other inner planets? Well, Mars has the most Earth-like climate of any planet, and it's possible for people to be able to live there. And the other inner planets are just absolutely inhospitable, and you wouldn't be able to survive on them. Which planet is almost the same size and mass of Earth? Well, that's Venus. Venus is our twin by size, mass, and gravity. All right, let's look at the outer planets. We're going to start with Jupiter, which is the closest outer planet. It's the largest planet in our solar system. It weighs as much as, or twice as much as all the other planets combined. If it was 10% bigger, it would have formed a small star. It's that big. It rotates in 10 hours. All the outer planets rotate very, very fast. But the further you get from the sun, the longer it takes to orbit the sun. So it takes about 12 years for Jupiter to orbit the sun. Jupiter also has 4 large moons. This is a picture of Jupiter. And Jupiter has these beautiful cloud bands in its atmosphere. This spot is called the Great Red Spot. It's a permanent hurricane on the surface of Jupiter. It's been there for at least 400 years since the first person, Galileo, looked at Jupiter with a telescope. I'm going to quickly run over the 4 large moons of Jupiter. You don't really have to know these, but they're historically important, so you may hear them referred to in other courses. Europa may harbor life. Europa has a lot of water. The surface of Europa is solid water ice, but underneath that there are probably liquid oceans. So if there's any other place in the solar system where life might occur in the oceans underneath the surface ice of Europa, the conditions might be good enough for life to exist. Then there's Ganymede, which is the largest moon in the solar system. And then here are the other 2 moons of Jupiter, Callisto and Io. These are the 4 large moons of Jupiter. They're sometimes called the Galilean moons. You don't really need to know these, but I want to mention them to you. Saturn is the next largest planet. It's the lowest density of all planets. It has a density of less than 1. Water has a density of 1. So if we had a giant bucket of water and we put Saturn in it, it would float. It rotates very quickly. It takes 30 years to go around the sun. The interesting thing about Saturn, besides its density, is it has the largest ring system of all the planets. All the outer planets have rings, but none of them can compare to Saturn. And of course, Saturn, being an outer planet, has dozens and dozens of moons. Here's a picture of Saturn taken by the Space Telescope, and you can see these beautiful rings. The rings are made out of small rock-like objects, chunks of ice that are in orbit around Saturn, and for reasons we don't understand, they haven't joined together to form a moon like our moon did. And Saturn also has some cloud bands that you can see. It's a very beautiful planet. The next planet out is Uranus, or Uranus. It rotates very quickly. The interesting thing about Uranus is that its axis of rotation is tipped over almost 90 degrees. All the other planets rotate on their axis like a spinning top, but Uranus rotates on its axis like a bowling ball rolling down a bowling alley. So it rotates this way, not this way. And the furthest planet away is Neptune. We know very little about Neptune. All the outer planets are very cold. They all rotate very quickly, and they all take a long time to go around the sun. So Neptune is mysterious to us. This is what it looks like. There are probes that are going to go to the outer planets that are going to arrive there in the next few years. We may get more information about these planets, but we really don't know a whole lot about them compared to Mars and Venus and so forth. Pluto is no longer considered a planet. We consider it a dwarf planet. And here are some of the reasons. It's very small. It takes over 200 years to go around the sun, and it has a weird orbit compared to the rest of the planets. Sometimes it's closer to the sun than Neptune. Sometimes it's way far away. Pluto is not considered a planet, and here's some reasons. One is it's solid. It's made of ice. The other outer planets are made of gas primarily. It's also very tiny. The other outer planets are humongous. And it has an orbit that's unlike any other planet. It's very unusual. So we don't consider it a planet anymore. Here's a size comparison of Pluto to the United States. And this is its moon, which is almost as big as it is. So you can see Pluto is very tiny. So hit pause. When you're ready, hit play and hear the answers. What is the largest planet? Well, that's Jupiter. Which planet has the largest rings? That would be Saturn. Which planet rotates differently on its axis compared to the other planets? That would be Uranus. Why is Pluto not considered a planet? Well, one is it's very tiny. The other outer planets are huge. It's made of ice. The other outer planets are made of gas and ice, primarily gas. What is the order of the planets from the sun outward? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune.